Good morning, one and all. Today we discuss about 4.6 Coulombs law. Okay, going to this class, we will discuss previous class, that is basic properties of. That is going to this class. We will discuss in the previous class, that is basic properties of electric charge. Electric charge. Okay, the first one is additivity. Additivity of charge. The additivity of the charge means we can adding the sum of the algebraic sum of the individual charges of the systems. Suppose system having number of charges, that is q1, q2, q3 up to qn. It having system having number of charges. What is the net charge? Net charge is nothing but that is total charge, or net charge is equal to sum of the individual algebraic sum of the individual charges, that is q1 plus q2 plus q3 plus q4 like up to qn. There is a additivity, that is like plus. Adding the number of charges, the system having number of charges, okay, that is algebraic sum of the individual of the systems. Okay, that is the total net charge on the system and a body is equal to sum of the individual systems. Okay, this is the additivity of the system. Okay, you know a relation between the mass and charge. Okay, the charge is depends upon mass, but not mass depends on charge. Okay, charges are two types, that is one negative, another one is positive. In the case of mass, only positive, we get the only positive substances. Okay, the relation mass is depends upon speed or velocity of the body, that is charge not depends upon the velocity or speed. Okay, you know already explained this relation. And now second property is conservation of charge, or charge is conserved. Okay, the charge is conserved is nothing but when a two or more bodies having, suppose one body having three charges, 1 2 3 charges, it is 1 coulomb, 2 coulomb, 6 coulomb. Okay, these coulombs you can shaking or it is converted into another form, it is another body. It is also having three charges. Okay, this total charge, it is plus 1, it is minus 2. Okay, here 6 plus 1 7 minus 2, how much? 7 minus 2 5 plus 5 coulombs, that is the net charge of the one body, first body. Okay, here one is 2 coulombs minus 3 coulombs. Okay, what is the remaining charge? That means we get the final, that means here 5 is equal to 3 minus 3 minus 1, that is minus 1 plus x. Okay, what is the x? X means it is goes to minus 1, that is 5 plus 1 is equal to x, that means 6 here, 6 coulombs. 6 coulombs, the net charge is 6 plus 2 8 minus 3 5 coulombs plus 5 3 coulombs. It is left hand side, LHS is equal to RHS, that means energy or charge is conserved, that is transmission of the only inside the body, the charges can be transformed to one place to another place. The transmission of the charges inside the body or system, but total charge is conserved. Here only for 5 coulombs, here 1 coulombs becomes 2 coulombs, minus 2 coulombs becomes minus 3 coulombs, here 6 is 6, okay, but remain 1 is, okay, that is total charge of the net charge is conserved. Here 5 coulombs is get one body, first body, the second body get 5 coulombs, that means the charge is conserved. Okay, next properties of the charge is quantization. Quantization of charge. Quantization of charge is nothing but this when is any substance having fixed amount of quantity, this type of phenomena is called quantization. That is, quantization is nothing but charge having quantization, that is 2 coulombs, 3 coulombs, 4 coulombs, like 1 piece of soap, 2 piece of not piece of, that means 1 soap, 2 soap, 3 soaps, like that is quantization. This quantization is nothing but Q is equal to plus or minus Ne. Okay, this Q is the total charge on a body. That is, Q is total charge on a body. It is N is the integer. N is the integer, is the charge on a electron. Charge on electron or charge on body. Okay, that is the Q is equal to plus or minus Ne. This quantization, that is N is integer, that is 1, 2, 3, 4, 5, like that. Okay, that is the quantization of the charge. That is called charge in a quantization. That means 1 coulomb charge, 3 coulomb charge, not on 2.5, 3.5, 4.5, like that. Okay, that means it is a integer multiple of integer. Okay, that is a quantization of the properties. Okay, now explain the Coulomb's law. Coulomb's law is the, it says the force in between the two charges. What is the force is occur in between the two charge carriers? Okay, that is charge is statement is nothing but the full Coulomb force, that is one having plus 2 charge, another one is plus, it is Q1 charge, it is Q2 charge. Okay, what is the force in between the two charge? The distance between the two charge carriers is equal to distance, that is R. Okay, what is the force in between the two charges? That is the Coulomb's law. The Coulomb's law states that it is a statement of the Coulomb's, the force of attraction or repulsion in between two point charges. Point charges is nothing but, that is two charges is very large distance, the object is very small. Okay, very separation is very small, sorry, very large compared to size of the body. Size of the body is very small compared to distance. This type of charges is called point charges. The force is proportional to the product of two charge carriers. Okay, the force of the in between the two charges is proportional to the product of the two charges, and also the force is proportional to the inverse proportional to the square of the distance. Okay, from this comparing from this equation we can write down the force is equal to F is equal to K Q1 Q2 by R square. This is the force, Coulomb force. Okay, this is like this. The F is force in between the two charge carriers, that is product of force is proportional to the product of two charges, that is Q1 Q2, and also the force is inverse proportional to the square of the distance between the two charges. Okay, can you remove the from the equation? There is from this from the above two concept we can write down here. F is equal to K Q1 q2 by r square. Okay, here okay, k is the 1 by, it is a constant. Okay, for constant, that is constant is equal to 1 by 4 pi epsilon naught q1 q2 by r square. That is a mod of q1 q2 or q1 q2. Okay, this force depends upon medium. This force depends upon medium. Here k is a constant. Here k is equal to constant, that is force is equal to k q1 q2 by r square. Here from this equation 1 by 4 pi epsilon naught q1 q2 by r square. Here k is equal to 1 by 4 pi epsilon naught. Okay, that is equal to, here k is the constant. Can you know epsilon naught, that is a epsilon naught is the permittivity of free space, that is constant. Okay, that is permittivity. The permittivity epsilon naught is the permittivity of the space, that is 8.85 into 10 to the power of minus 11 Coulomb square by Newton meter square. Okay, that is k constant, that is 1 by 4 pi epsilon naught, that is equal to, you know, 4 value, pi value, epsilon naught value, you can substitute, we get the k constant value is equal to 9 into 10 to the power of plus 9 Newton meter square by Coulomb square. Okay, can out here k is nothing but, you can simplify this equation. K is equal to f r square by q1 q2. F Newton units, Newton r square meter square by Coulomb square. It is units of k. This units of k, Newton meter square by Coulomb square. Okay, Newton meter square by Coulomb square. That is this. From the above equation, from this equation, F is equal to k q1 q2 by r square. If q1 is equal to q2, both are having same charges. If both q1 and q2 are the only 1 coulomb, here 1 coulomb, we get here 1 coulomb, r is equal to the distance 1 meter. Okay, we can, what is the force in between the two charges, that is F is equal to, we substitute in the formula. Okay, here q1 is equal to 1 by 1. Okay, 1 by 1 is equal to nothing, that is k. F is equal to k, that is F into, F is equal to 9 into 10 to the power of 9 newtons. Okay, that is the force when two charges are having 1 coulomb, the distance between the two charges is only 1 meter. You get the force is equal to 9 into 10 to the power of 9 newtons. Okay, if from the above equation, that is F is inverse proportional to the square of the r square distance, that is the inverse square law. This is also called inverse square law. Okay, that's inverse square law, that means it is a variation of the distance or separation and also force. Okay, here from this equation, distance, here force increases, the distance between the two charges is decreases. Small distance between the two charges, we get maximum force. Suppose two charges having highest charges, we get the force is high, that means force is high, we get the, when we get two charges having more coulombs, more charge, we get the more force. And also the charges separated between the small distance, we get the highest force. Suppose large distance, r is very high, we get small force. Okay, we get the small force. Okay, this is the relation. F is inverse proportional to the square of the distance. Okay, that is the square of the inverse square of the inverse square law. Okay, that is variation is like separation between the two charges is increasing the separation, the force will be decreases. According to from the diagram graph, the force is decreases when separation of the two charges increases. Okay, that is the inverse square law. Okay, from the above equation, suppose if R, from the this equation, suppose R is equal to 2R, we get F is equal to F dash. The resultant force is equal to F by 4. The resultant force is becomes a F by 4. That is 1 by 4th of the force when the distance is double. The force is decreases. Suppose the distance is half. The decreasing the distance, the force is fourth time is increases. Okay, that is the relation between the, that is the applications of the Coulomb law. Okay, now we will discuss limitation of the Coulomb's law or vector form of Coulomb's law. Okay, this is Coulomb's law valid for only point charges or static charges. Point charges is nothing but the size of the body is very small compared to distance between the two charges. Okay, suppose let us consider here two charges like here, one is Q1 charge, that is Q1 charge, it is Q2 charge is separated by a distance from O, that is O to Q1 is the distance is R1. Okay, and also Q2 charges from O, that is R2, that is separation between the two charges, that is R21 is equal to R2 minus R1. Okay, that is a vector form of charges, two charges. Okay, suppose in a force acting on a first charge F12 is the force on a first charge due to second charge, that is F12 is the force on a charge Q1 due to charge 2. Okay, that is F12. Okay, that is force, it is a repulsive force, that is force is positive charge carrier, that is positive. Okay, that is repulsion force, that is F12 is like this side. Okay, in the same force and the second charge, that is Q2, that is F21. F21 is nothing but force due to second charge, F2 force on a charge Q2 due to Q1. Okay, that is F21. Okay, this is also the force on Q2 is F21 is in this side. Both are in the repulsive forces. Here the repulsive forces or attractive forces is occur in between the on the basis of the charges. Suppose we can taking both negative or both positive or positive negative. No, what is the happening? That is the applications of the Coulomb's law we want can be explained. Okay, now this is a F1 to force is on charge 1, F2 force on charge Q2. Okay, this force is occur, that is separation between the two charges is here R21 is equal to R2 minus R1, that is from R21 from here to here. Okay, yes, from center or O, that is from O to Q1 R1 distance for center or O to Q2 distance is R2. Okay, we can apply the vector form. Okay, there is r21 is the vector leading the from first to radius to first to distance to second distance. Suppose you can taking first from r12, that is distance from r1 to 2, that is like this. Suppose here from here, that is from 1 to 2, that is r1 to here, from here to here r21. Okay, from here, from center to from left to right to left r21, left to right r12. Okay, that is the same. r21 is equal to r12 is equal to minus reverse direction. It is r12 is forward direction, r21 is reverse direction. Both will be the same magnitude but opposite direction. Okay, and also the magnitude is same. Okay, the equal opposite direction. Okay, that is in the vector form we can write down r21 is equal to r21 by mod of r21. Okay, r12 is equal to vector form, that is r12 is equal to r21. So r12, this is the magnitude of the vector form of r21, r12 can be in a vector form. You can write down in the case of f is equal to k q1 q2 by r square. Okay, suppose if this is a general formula. Okay, suppose we can apply the f12 is equal to k q1 q2 by here r12 square. Okay, it is a okay, in terms of it can be written as in the form of vector form like this. Here f12 is equal to k q1 q2 by here r12 square is equal to r here r12 bar. Okay, this can be written as f12 is equal to k q1 q2 by r12 mod square by r12 bar. It can be written as k q1 q2 by r12 square into r12 cap. Okay, from this above relation, from this equation or this equation, you can write down in the place of r21 is equal to r21 bar is equal to here r21 by r cap. Okay, again simplify this equation like this. f21 is equal to 1 by k or 1 by 4 pi epsilon naught. Okay, yes, 1 by 4, f is equal to k1 by k q1 q2 by r square. It is general formula, Coulombs law. Okay, we can apply the for first charge at this charge q1, the force is like this f12. Okay, thus f12 is nothing but 4 pi epsilon naught q1 q2 by r21 square into r cap 21. Okay, this is the relation explanation. Okay, in the case of second and q2, at q2 point the force is f21 is equal to 1 by 4 pi epsilon naught q1 by q2 by r21 square is equal to r21 cap. Okay, r21 cap Okay, from this is a vector form of and second charge. Okay, from this equation we can conclude that F1 2 is equal to, it is a vector, force is a vector, it is a vector form. Okay, is equal to F21. Okay, here from this equation we conclude that these forces are on a first charge due to first charge of force due to second charge, and your force due to on second charge due to first charge. Okay, always having same magnitude but opposite direction. Magnitude is same magnitude, the forces having on a two charges, same magnitude. Okay, here F21, F12, okay, same magnitude but opposite direction. This is this direction, this is this direction, opposite direction. Okay, here, okay, here F21 is equal to minus 1 2, that is having same magnitude but opposite direction. This is the agreement with Newton's Newton's third law. Okay, some limitation of the Coulombs, that means we can consider one sphere or circle. Okay, inside up to surface, on the surface, suppose here sphere, okay, up to surface the charges are positive or negative. Up to surface we can consider this total charge, net charge is equal to what. But outside of the charge or outside of the circle, outside of the sphere, okay, outside of the spherical, okay, that is we not considered as a total charge, we not considered. Okay, that means closed loop, inside the loop or body or system we can find the charge of the body. Okay, that is a point charge or another charge. Already this can be explained. Both charges are in at rest position, we can consider as we can find the forces. Okay, suppose both are at motion, we can't find the, not observe the Coulomb's law, it will not obey the Coulomb's law. That means here one charge is in motion, one charge is at rest position, it can be applicable the Coulomb's law. Suppose if in a hair or free space the force is equal to K Q1 Q2 by R square, that is K value, that is in a medium free space, that is 4 pi epsilon naught. Epsilon is the permittivity of this free space or air, that is Q1 Q2 by R square. Suppose in a medium, suppose in water, in glass, okay, in another medium, that is medium, the force is Q1 Q2 by 4 pi epsilon. Here epsilon naught is the free space, permittivity of this free space. Here epsilon R square, epsilon is the permittivity, epsilon is the permittivity of medium. Okay, from this ratio of the free space, okay, force in a free space by force in a medium is equal to, the ratio is K cancel, R square cancel, both are will cancel, remaining terms like epsilon by epsilon naught, that is epsilon by epsilon naught is equal to epsilon R is equal to K. Okay, K is the dielectric constant, epsilon R is the relative permittivity of the medium. Okay, epsilon R is the relative permittivity of the medium, K is the dielectric constant of the medium. So like this. Okay, now we can explain some problems. Okay, suppose two charges having in here, the force is 10 newtons. Okay, the medium having dielectric constant K. What is the medium force? What is the force at medium? Okay, relation, that is equal to F by Fm is equal to K. Here K is equal to given to F in a hair, that is free space, that is F is equal to, here what is the force in a medium. Okay, F by Fm is equal to K. F K. Okay, we can find the force in a medium. F by k, 10 by k, that is we get force in a medium is equal to 5 newtons. Okay, problems are coming. This is the important for problematic. Okay, thank you. Okay, now okay, another one relation, the relation between the electrostatic force and gravitational force, both will be in the Coulomb's law. Okay, that is F is equal to k q1 q2 by r square, that is electrostatic force. It is the gravitational force. Fg is equal to g m1 m2 by r square. Okay, in this one, in the equation number 1, in the equation number 2, similarity is same, that is F is proportional to the 1 by r square from the equation number 1. From the equation number 2, Fg is equal to 1 by r square. Both will be in the similarity is same, that is 1 by r square is the same in between the equation number 1 in the equation number 2. And also both are acting along the line joining the center. The lining center, it is line, it is q1 q2, both will be at lining joining the center, that is f1 to this side, f21 is this side, that is lining joining at the center. Okay, that is difference is between the two forces. Repulsive force, that is Fe, electrostatic force having repulsion as well as attraction force, but because two charges having, suppose here plus repulsion force, suppose one is minus, is plus, it is attractive force, both will be minus, it is repulsion force. Okay, like charges having repulsion forces and like charges having attraction forces, that is electrostatic force having two types of forces, that is repulsive forces as well as attractive forces. In the case of gravitational forces having attracted forces, because having masses is always having positive charges. Okay, that is in the case of gravitational force independent of the medium. Okay, in the case of Fg, that is gravitational force is g m m1 m2 by r square. Okay, it is not depends upon medium, it is a gravitational, that is constant, universal constant. In the case of force electrostatic force, that is k into q1 q2 by r square. Here is k is the dielectric constant. Dielectric constant is depends upon medium, that's why Fe depends upon medium, gravitational force independent of the medium. Okay, and also the electrostatic force is always greater than the gravitational force. Okay, you know gravitational constant, that is 6.67 into 10 to the power of minus 11 Newton meter square by kg. K is equal to 9 into 10 to the power of 9 Newton per meter square by c. Okay, one can do the one problem is there. Okay, find the ratio of the electrostatic force to electrostatic gravitational force for two electrons. Okay, two electrons are placed at a some distance apart from the two distance. Okay, suppose two electron, there is a one electron. Okay, the separation is there. What is the electrostatic force by gravitational force? What is the ratio of the electrostatic force? Okay, you know from the solution, the electric charge E is equal to 1.6 into 10 to the power of minus 19 coulombs. Okay, you know electrostatic force, that is Fe is equal to k q1 q2 by r square. Here Fg is equal to g m1 m2 by r square. Here suppose the ratio of Fe by Fg, Fe by Fg is equal to, here r cancel, that is k q1 q2 by g m1 m2. This is a formula. You know k value, k is equal to 9 into 10 to the power of 9 Newton meter square by Coulomb square. G is equal to 6.67 into 10 to the power of minus 11. Okay, electric charge q1 or q2 is equal to 1.6 into 10 to the power of minus 19 coulombs. Okay, charge of the electron, mass of the electron, that is ME is equal to 9.1 into 10 to the power of minus 31 kgs. Substituting these values, okay, substituting these values, like Fe is equal to the ratio of the electrostatic force by the ratio of the electrostatic force and gravitational force. Okay, you know K value distributed between two electrons. It is the charge of electron, mass of electron, mass of electron. Okay, you can substitute this equations. We get here K value 9 into 10 to the power of 9, here 1.6 into 10 to the power of minus 19 Coulomb square. Okay, Q1 Q2 O square divided by here G value 6.67 into 10 to the power of minus 11 into 9.1 into 10 to the power of minus 31 kgs square. Okay, after simplify we get Fe by Fg ratio is equal to 10 to the power of 42. Okay, this is the ratio of the electrostatic force by the ratio of the electrostatic force by gravitational force. Okay, Fe medium, the Fe by Fm is equal to epsilon by epsilon r is equal to K. K is the dielectric constant, epsilon r is the relative permittivity, epsilon is the permittivity medium. Okay, epsilon naught is the epsilon naught, that epsilon naught is the permittivity in free space. Okay, F is the force in free space, Fm is the force in a medium. These are the relations. Thank you.